All right, and we are live. Welcome back to Kong Builders. I'm your host today. My name is Victor Gamov, and as always, you probably here to get some cool new information about things what we do with Kong. And as a reminder, in the Kong Builders, we doing some stuff live, and some things will break eventually during this live stream. And today I'm super excited that I'm not alone in my studio. I'll have my friend Greg Hunt to talk to me a little bit about stuff that he did for Kong Builders. Greg, welcome to Kong Builders.
Thank you for having me, Victor.
Yeah, I just said Kong Builders, but I meant the Kong Summit. So Greg was one of the speakers in our annual user conference called Kong Summit, where we were talking about all things Kong and not only, right? So we talk about service mesh, we talk about Kuma, and we thought that, okay, so not many of you were able to join us, and since we didn't do any kind of like a formal recording of this stuff, we will start bringing some of the guests from our Kong Builders, for our Kong Builders or Kongcast shows. So, before we jump right in, let me see if we are... Okay, we see that the people are seeing us here. And looks like so let's do a quick round, like where are we coming from? and what's your level of using Kong? So let's do some comments. I see some of the regulars here. Let's see. Thank you so much for showing up and showing some love to Kong demos. That's what we do here. Gateways and pipelines, cool stuff. Okay. And yes, our Kong Kong account says welcome everyone. So it looks like everything working. I haven't done this for a while, and maybe something will break. But let's, before we jump, like Greg, what brings you here? Like when you start using this stuff, how you build your expertise in the field of service mesh, and like what are you going to be showing us today?
Yeah, certainly. I've been working in healthcare IT, building APIs and integrations for the past 10 plus years. One of my more recent projects, we were building on top of Kubernetes. And in that setup, I was leveraging Console, Vault, some other tools like that, and ended up falling in on using kind of Kong as my ingress gateway. With that, I was having some challenges with Console and Kong, and that actually led me towards Kuma, which is kind of what my session is about today. And so with Kuma and Kong work really well together. Kuma is the service mesh, if you're not familiar, that Kong mesh is built on top of. It's the open source project. I believe Kong donated to the CNCF last year or year before.
Yeah, year before, and right now Kuma is in a sandbox, and in order to go out of sandbox, there should be like more use cases, more and more community. So it's great that we're getting some contributions from people who are not employed or working for Kong, for that matter.
Also, I'll give that team, they have a monthly community meetup type session. You should join if you're interested in service mesh, because they are always willing to talk to anybody who joins and very open. And you will not find that in a lot of other service meshes where you can actually talk to the developers and kind of have if you're using it, can kind of help mold the direction of the product.
And the thing is, with this, if you missed for some reasons, we always post all these recordings from user calls. So don't forget, where is it? Don't forget to subscribe. You should probably go somewhere here and click that subscribe button to this YouTube channel, so you will get all things service mesh, all things Kuma, all things Kong in this channel. All right. So so as I mentioned, Greg was a speaker for at the Kong Summit, and he shared some of the experience that he developed around managing some of the I would say it's quite challenging topic in general. Like I will pass this to Greg's, and he can talk a little bit about this. And I will be here looking to the chat and translating some of the questions, and we will be have as much as interactive session as we can. And the purpose is for us to share and you to learn, right? And we're here to answer any questions.
All right, so this is a session that, like I said, Victor said that I did at the Kong Summit. Where this came about was actually just some side conversations that I was having with my friend Nicholas Jackson, who is a developer advocate with Hashicorp, and we were talking about Kuma and specifically a lot of the token management in both Console and Kuma is really has been more focused on the Kubernetes side. One of the things I liked about and the Kubernetes authentication method, which is very different than outside of Kubernetes. And so one of the things we liked about Kuma was that it was using JOT tokens for managing access to the data plane. And so with that, we said, though, the only problem was that was generating those JOT tokens was a one-time thing, and it tended to be long-lived tokens. And we said, well, that's not really great practice. So what we should do is we should be able to manage these more dynamically. And we're like, Vault actually does a really good job of managing JOT tokens dynamically. So
Yeah, or
we could really
any
take
type of secrets for that matter, right?
yeah,
So,
yeah, right. And so especially if a group and a lot of large corporations and small corporations are using Vault for secrets management, whether that be dynamic database secrets or key value stores or whatever, those are in place. So what if we got together and wrote a plugin where we could actually have a Kuma control plane or Kuma token secrets engine? And so that's exactly what we did. So this demo is showing off that plugin. That plugin, at the end of this, I'll give you the GitHub to that plugin and to the demo I'm going to show today, where you can follow along with both. We're going to continue to be adding new features to that plugin as we go, and adding more and more functionality into it. So we're definitely looking forward to that. So with that, I will kind of start into the demo here. The slides is not a huge portion of this. It's more demo focused. So I'm going to go through the
Doran
slides
says
first.
hi from France. We got our another champion, Mert, comes from LinkedIn this time, and he says that they're running 10 services and tackle moving to Kuma to get more manageable architecture. And Tony TV heard some bad news about Jot lately. So Tony, do tell while we will continue. Throw some of the news, and we're getting back.
Perfect. So we'll go through the kind of the agenda of this. So the setup, the problem, what our solution ended up being, and then obviously the demo of how it works. All right, so the setup. The setup is that we have Kong, and we're routing traffic into our mesh. We're leveraging Kuma to manage the control plane and the mesh. The problem is token management. Right now, this is a very manual process driven by policy. This is a time-consuming process because you need to go, especially if you're in a large organization, you need to actually go through, request someone to generate you a token, send you a token, which also causes delayed access. This can be error-prone. If you don't properly request the scopes in those tokens or properly request, then you have to then go back to the beginning and redo this. And it ends up not being sustainable. And what eventually happens is people circumvent it. They create tokens with too high permissions so that they don't have to keep going back and asking for tokens. Ultimately, that ends up leaking secrets. Raise your hand if you've never committed a secret into GitHub. I think everybody has done that at least once.
And again, this is not the good practice to do so, right? So,
right.
I have a question. So, what kind of where inside the Kuma we use these tokens, and why it is important to include this? Like, if we will just why we need to do this, if we would say just encrypt the traffic, so traffic is encrypted.
So what this
why bother?
Correct. Yeah. So what these tokens do is they allow services to join the mesh, right? So in order for you to join the mesh, you need to prove that you are the service you are. And inside of and so Kuma takes your permissions and bakes them into the token. And so then when you go to join the mesh, you have a config file for the data plane that tells you what you're going to do. It then compares the token, the permissions in the token, to the permissions in your config file. And if those don't match, it doesn't allow you to join the mesh. And so that's a way for services to be able to join the mesh and verify that you don't have a rogue service try and join your mesh, and then you route traffic to it, or then it interacts with other services in your mesh. And so that's the purpose of these tokens. And so that's what...
And again, here's a very important thing that we would like to point out is that essentially in the Kubernetes, some of this automation is handled by some of the when you do injection of the sidecar, some of the configuration will be shipped here. But in environments where are not Kubernetes, the things with adding services to the mesh would be slightly different. And this solution should work both for Kubernetes and for non-Kubernetes environment.
Right, and in Kubernetes you have the service access tokens that can kind of help with that right? And so you can write rules around those access tokens where outside of Kubernetes world, you have to kind of maintain, handle that separately. And that's really the solution we're kind of driving through here.
Yep.
So next, our solution. All right, so we need a token management solution. All right. In this example, our enterprise is already using Hashicorp Vaults for certificates and dynamic database access. Vault is built on a plugin system. Vault already supports many auth methods. Kuma is API first, which meaning all of the token generation and everything can be directly accessed through their API. Vault can manage the life cycle of tokens. That's an important thing that we're going to kind of show later in the demo. So let's write a Vault plugin, which can drive the Kuma API. We can work this into our existing workflows with our existing in-place auth methods. So now I'm going to kind of give a little overview, specifically since this is more Kong focused if you're not familiar with Vault and its process, the Vault authentication workflow.
And
so in the Vault authentication, go ahead.
Yeah, you broke up real quick. I'm not sure if anyone noticed, but start your sentence once again from beginning.
Yeah, no problem. So for those who are not familiar with Vault, I'm just going to go through a quick example of the Vault authentication workflow to help understand in the process. So you connect to an authenticator background like LDAP or any sort of authentication method. And then the security team writes a policy that checks, that gives you a policy associated to that authentication method and backend. We upload the policy to Vault, and then we map those policies to those authentication methods. So if you're in a specific, an example here, if you're in a specific LDAP group, you're mapped over to a specific number, which can be one-to-many. It's really end-to-end relationship between policies and authentication method roles, and you can then be given access to those things inside of Vault. Now, in that workflow as well, as a user, you would authenticate with your LDAP creds. The Vault would then hit LDAP and verify those creds. It would then pull the associated policies attached, and then return you a Vault token with those attached policies. And then with those policies, you can then request secrets inside of Vault. All right, so then we're going to explain how our specific workflow works with that. So we're going to run a Vault agent on our system. Our Vault agent is basically just a long-running process that will actually be able to authenticate as a service inside of our service. We're going to be using AppRole, which is basically a secret and an ID that we inject inside of our services. But you could very easily use an IAM, any sort of cloud metadata as your authentication process as well, which would be more common in a real world case. I'm running a local instance, so we're going to use AppRole to kind of simulate that IAM metadata for authentication. So you would authenticate against Vault, and then so what the agent will do is we'll authenticate against Vault and then get back a Vault token. Now, we're not interested in the Vault token. We're interested in the Kuma token. So then on behalf of the Vault token, we'll then request a dataplane token based off of the config we put in the agent, and then that will return back the dataplane token. And then after, it will then actually take that dataplane token and start the dataplane service, which will join our policy. On the back end, when we make that request to the dataplane token, Vault actually on our behalf goes and uses an admin token to generate the control plane token and then return that back and then proxies that through. What's cool about Vault is Vault keeps that stuff in memory. It doesn't actually ever store the actual token. So it maintains its secrecy through the entire time. So only this user will end up with that token. Then they can use that token to join the data plane, obviously. So next. All right, so then we're going to show the plugin in action now. Here's a GitHub links to both the demo I'm going to show today and the plugin. They're publicly out there on GitHub. You can take a look. Please feel free to put in issues, make comments, make suggestions, make PRs as you wish.
Yeah, hopefully PRs.
And
We'll pour some code there.
yeah, and that's yeah. So this is where you can access that. So now I'm going to jump into the demo.
Yeah, let's take a look how this all look like. I have so many questions.
Yeah. Okay. So I'm using Shipyard as my engine. Shipyard is a demo tool that is really kind of like Docker Compose with dependency built into it. And so and also on top of that, it has interactive documentation you can build into it. So that's what we're going to drive today. So I'm going to run the Shipyard blueprint, which is essentially what the demo repo is the Shipyard blueprint. All you need is the Shipyard runtime and Docker to do this. So what this is doing is it's going to go through and
Can you
it's
walk
going
us through
to
this like a Shipyard blueprint so we can see what is going on
I
there?
certainly will. Yes. All right. So here is my Shipyard blueprint. So what I have is in here I have my Kuma control plane, which I actually created as another blueprint so it could be reused. It's like a module inside of it. And this is just the basic control plane. Inside of you build a network inside of Kuma, which is just a Docker network. In here, you can copy files. So I create a backend file that I can, these are my config files for the different API endpoints. And then I'm actually using, at this moment right now, I'm using Shipyard to generate the certificates that are being used by Kuma to generate the tokens. I'm injecting those directly into the Kuma control plane instance. Long term,
that blueprint things look like very much like a Terraform module.
It's very similar, yeah. And it was written by Shipyard itself is written and maintained by Nick Jackson and Eric Veld, who are both European DAs for Hashicorp. But it's great for doing dependencies, and that's what makes it really nice in this instance. So now throughout here, I have a series of HCL files that are managing the different other components. So I have Kong, where I have a container. I have my dependencies that these other things need to have run first before it can bootstrap up these containers. I can add volumes directly into here, like the app role secrets that I'm injecting into these different containers, very similar to way an IAM metadata would do, as well as things like the address of Vault and things like that. I have a container that's running Vault. Inside of there, I have a config script. That config script goes through and it creates the default Kuma config secrets engine, configures it for me based on my URLs, and then creates a number of roles for this specific demo. So that happens there, and then it also generates the app role secrets and IDs, which it saves out to files, which then are mounted as volumes into the other, both the Kong and the payments, and then several other, the database and the backend pieces. So that's how kind of that works. And so you can go. This is all up there in the GitHub. And you can take a look and review through it.
So database,
now
mean it's a database that the Kuma control plane will be using, or it's a different type?
No, in this case, this is really just a fake service that's named database, but it is simulating a database that would be in your network. So if you had a database running in your network.
And you want to
let's
add this database.
Interact with it, yeah. Yep. So we'll go and we'll hit so when we first come up, there was no connection, and then once Kuma, all the data planes came up, everything was connected. So this is fake service. Fake service gives me a GUI implementation of how we're connected. So this is the Kong API, or the Kong container that's running, and I'm hitting port 8000, and I'm hitting the UI on that container. That container then is hitting the API, is being routed from Kong into the API service, which is then connected through Kuma to the database service. So now we can go look at that actually here in Kuma. So let's refresh Kuma, and you can see that I have 3 services running and 3 data plane proxies up. If we go to our internal services, you can see that I have the Kong service, which is a gateway service. It's bringing the traffic in, and then we have both the API and the database service inside of our mesh. And that's what we have so far in this specific instance. All right.
If you like a first time seeing this, the Kuma UI is a part of control plane. So if you deploy control plane, you will be able to access to GUI and see some of the things that's happened. And also, if you could scroll on the left side a little bit, you will see there's two types of data planes. There's the standard data plane, which is our applications, and the one that gateway, it's going to be Kong stuff. Yeah, this is our applications. Yep.
And you see these tags. These tags are associated to a service. That's how you can set up different rules and routes inside of Kuma. These also have to match in the JOT token that gets issued to join the data plane. That's one of the things they need to match, and it verifies those. And if they don't, it actually doesn't allow you to join the mesh. So, yeah. And this is very zoomed in, so that you can see on the screen today. If you zoom out and you're running it locally, you can see the dashboard on a large monitor has everything very easy to see compared to the zoomed in view.
Stats from the YouTube streams tell us that a lot of people watching this from their phones, maybe they're using lunch break and having a meal. Bon appetit, how we're saying here in New Jersey. If you're watching us and also consuming some delicious foods. Also, another stat said us that a lot of people watching these streams are not subscribers. Please do subscribe and get notified when the new content will come in. Okay, that was my moment of the plugin and some other advertisement. So right now is just the plain service, right? The two services, API, database, and gateway. So typical architecture.
All right, so now I'm going to go through the interactive documentation inside of Shipyard. So when Shipyard boots up, it will have a docs endpoint if you configure it. And in that docs endpoint, I've gone through the different set up this interactive demo that we can just drive right through. With that, it actually has small little terminals here that are actually mounted to these different boxes. So this one is local. This one is in the Kuma container. This is in the Vault client. I have a Vault client sitting that I can show how to interact with Vault, and then the actual Vault server. All right, so installing and configuring the plugins. First thing we're going to go into about how would you actually just install this plugin in your own system, right? So we're going to check to make sure that we have a connection with Vault. So we hit the Vault status on the Vault client. This gives back the information about Vault. Yes, it's up and running. We can also go to the GUI, and I used a super secret password in order to show you this is our initial Vault instance, and it actually has the one Kuma plugin installed right there. So then what we're going to do now is, and I'm going to make this bigger as I go through here. Yeah, there we go. All right. So the next thing you want to do is you want to register the plugin with Vault. The plugin needs to be on the server to do this, but one of the things you want to do is you want to make sure that you use SHA-256 to verify the plugin. That is because this is verify the binary. Sorry, the plugin itself is an executable that interacts with Vault server through RPC. Mm-hmm. So it boots up beside Vault. Vault then makes RPC calls into it, and that's how it interacts with the plugin.
Is it
because this is
is it some sort of sorry for interrupting. I was just trying to kind of have this interactive as possible, so I can also learn something in this regard. So this RPC, the protocol, is it like a Unix socket type of communication? It's a defined set. So basically, and when you go to build a plugin, you get a basic it's all in Go. So you get a Go shell, and which has specific endpoints stubbed out, and then those are the calls that it's expecting to get, and then you
implement your implementation from those endpoints.
It reminds me. Go ahead.
So it's really pretty easy to get going if you have written any kind of Go. So
It reminds me the way how external plugins work with Kong. For example, I did the stream when I showed how we can develop a Go plugin for Kong, and it's actually follows like very similar idea. Have a Go.
I think it's very, very similar. I think it's basically the same backend technology that's working on there. And so this is one of the things you always want to make sure when you're using a plugin like this that you get you verify the binary, because that's obviously a point of injection. When you register the plugin in the catalog, you put the SHA. That way, if someone was to get onto that machine and swap out the binary, the Vault system would see that and verify that the SHA was different than the binary, and it would not allow that attack. So that's an important piece when you're doing these plugins. So we're going to go ahead and show. So we're going to do that and run that on our client. We're going to write the command in here, and you can see that actually writes that plugin just like it was there, and you can see that was successful. All right. So now the next thing you want to do is enable the plugin. So we already have one called Kuma. Each path needs to be unique. We're going to do another one called Kuma Guide, just as an example to show how that process would work. So we need to enable the secrets. So the plugin is there, the plugin is registered, and the SHA is set for the binary for that specific one. Now we need to actually tell Vault, hey, use this plugin. So what we're going to do is we're going to run this command right here into the Vault client terminal. So now we run this command, Vault Secrets Enable. We're going to add path Kuma Guide, and then we're going to tell it that we want to use the Vault plugin Kuma to do that. And you see we get a success back, and it's created a secrets engine at Kuma Guide. So if we go back to Vault and we go here, you see now we have another one, Kuma Guide. That's the one we just created right now, and that is the Kuma secrets engine. All right, go back to our documentation here. All right, so then after that, you have it up and working, but it's not configured yet. So what we're going to do is we're going to configure it. In order to configure it, right now, you basically need you only need two things. You need the URL to the Kuma control plane that you want to create tokens for. One cool thing about this is actually, because you can have multiple routes here of the same plugins, you could actually maintain multiple Kuma control planes and just have different URLs in the config for each one, and do that as well. So
is it something that would be useful for multi-mesh type of deployments, where you have a few control planes based on different meshes and one global control plane?
Definitely would be able to. And you could write policies around which teams could access which meshes based off of which groups they're in, and give permissions based off of that. So we have to add in the URL of the control plane, and then we also need to give Vault a valid admin token that it can use to actually perform API operations against the Kuma URL.
So it's a part of the plugin.
So
when you will be requesting, or like dataplane will be requesting.
Correct.
Underneath, or like how you call it, like on the back, the Vault will do what's the word I'm looking for? Like admin, like godlike mode call to.
Correct. That's exactly right. Yeah. And in this case, that admin token is persisted in the Vault secrets engine in such a way that it can't actually be pulled back out. You can view the URL in the config, but you cannot, once you post that in there, you can't pull that back out. So then we will do. So here we have actually. So if I go back to my client, you can see this is interactive, because I'm going to do a print env. And this isn't just like visual here. This is actually a client inside of this container that's running through Shipyard. But I have set, in here, I've set the Kuma URL as an environment variable. So what we're going to do is we're going to write the URL and then also the Kuma token. And the Kuma token is in here as well. And it will pull that in. Well, here we go. All right. And so now we have run the that, and we've
Configuration
configured
into
the
this
config.
particular enabled plugin.
Correct. Yep. So we did a vault write into the Kuma guide path. That's the one that we just created /config, and that we've set the URL to the URL, and then the token to the token. This little ampersand here means actually the contents of a file. This Kuma token environment variable is just a file, like a link to a file. Let's see. Yeah, see, it's just a link to the admin token. So what this will do is this will actually take the contents of that token and put it in there and send it in. That's what that little ampersand does there. All right. Okay, so now we've done that. So now we have our configuration set up. But now what do we need to do next is we need to create roles. We need to create roles so that we can actually do something with this plugin. So in our plugin, we've created the ability to set the parameters of token name, mesh, and groups are the different abilities that you can set as parameters, as well as tags. Groups are for user tokens. So if you are a user and you want to interact with the Kuma control plane API, services need the ability to, they have to have like token name and tags. Again, it's all JOT. We should have short-lived tokens in order to, with expiration, so that they are less volatile out there.
What would be, in your opinion, what would be like ideal expiration time for the service, and maybe also like give some recommendations around how the people should, configure, or how people should generally approach this type of problem, like what things need to be considered?
Yeah, so there's two aspects that Vault maintains, which is the TTL lease and the max TTL. So the TTL, which is the lease, is how long that token is good for until it will actually revoke the token. Okay, the max TTL is actually the lifetime set in the token. So in this case, I'll give you an example down here where we're creating this role. We are setting the TTL to 1 hour, but we're setting the max TTL to 24 hours, which means when we mint that token, we're minting the expiration date in that token at 24 hours. That's how long the token itself is good for. But if you don't renew the lease on this token within an hour, then Vault will actually revoke that token. It will go. So in Kuma, there is a secret that you add the JTI to, and that will invalidate that token. So if you try to use that token and you haven't revoked your lease, it actually pulls it and you can't use it anymore. So that's actually a good balance. And Vault Agent it uses an example of where you can have that process happen automatically. So your agent requests a token. Let's say you set that token is for 72 hours as max TTL, and then you set your TTL for 6 hours. That would mean that every 6 hours, the agent needs to go and refresh the lease on that token. I believe the agent is set to default to do that at the 2/3 mark. So once it's 2/3 of expiration, it will then, so I think on a 6 hour, it'd be like about a 4 hour mark, it would just go ahead and automatically renew the lease for you. And then when it gets to the end of the max TTL, you can set it to also where it would automatically generate a new token and then bump and rejoin, bump the data plane.
Makes sense.
So yeah, if you are a person,
how the service will get this updated token, like the process of updating token, if you are like sunny day scenario, like if you eligible to continue to do this, how this going to be looking on the long run for people who
you would configure. So, and this is where I would definitely recommend using on a service the Vault Agent, and the Vault Agent can actually do it depending upon how your executable at the time needs to be. So in this case, it would update the token, the config file. It would update the data plane config, and then it would do like a sig up to the process, and the process would know, hey, I need to rejoin. I believe, and I have to go verify with the Kuma team, but I believe they actually added in some new logic just recently where it actually constantly is rechecking. I think every minute or every so often it's going to actually start rechecking that, where that process will happen naturally. and you don't have to even do the sig up. It will check for an update there. And that it does that on as well, so that if you have an expired token, it'll kick you out. All right. Group meshes. All right, generate user tokens. So let's do this. Okay, so then now we're going to create this token in the default mesh. The token name is going to be Jerry, and then this group is going to be the system admin. All right, so we run that command. Now we've created that role for Jerry to then be able to come in and request a token. Now, how do we generate the user tokens? So what we need to do is we need to read from that user token, read from that terminal. All right, so we're going to do a vault read. You have to have a vault token. So you would have to authenticate with whatever your authentication. I'm already authenticated in this. And then you will need to then do a read on that admin role, and that will get you back your token. You'll get back a lease ID. That's how you would renew your release, is with this, this lease ID, the duration of the lease, if it's renewable or not, and then actually the token. So let's go ahead and do that. Now we have the token. Now, if we grab this token and copy it, and
famous GWT Jot Explorer website.
Yeah. And we paste it in here, you can see that we have a token, you have the JTI, the expiration, and that it's in the group admin, and the name is Jerry. And this is what you would need to join. All right. So now we have our user token. All right. And then we want to grab the content. Oh, yeah, we did that. So you want to use that piece in order to verify that we can. Actually, I think this does the same thing. Yeah, this will take and write out the token. You need to use this token as the bearer token to call the API. We can do that here, and you can see that we run that, write the token out, and then we put it into the bearer when we do a curl, and we get back a response from the Kuma control plane. On that specific secret we read that there are none, but we're hitting the control plane API with our token.
If we will hit this API without a bearer token, what we'll get?
Yeah, here, let's do that. Access denied.
Beautiful. Beautiful. That's what we wanted to kind of like achieve.
Yeah. All right, and so you should get this request back. Okay. So now what we're going to do is I'm going to, and I want to do this, I have a limited amount of time. I think I set an hour for those other services that I just booted up before they get kicked out. So all right. So now we're going to go into the actual process of automatically generating as a service. All right, so automatically generating tokens for our data plane registration. We're going to use the Vault agent for that. All right, and you can go on the Vault project and look at how that works. We're going to be using app role, which is just a secret, an ID, a client ID, and a client secret to simulate what it would be like to use like an AWS IAM or any sort of metadata authentication, and all of them are supported through Vault. So we need to create a role. We're going to create a role. Right now we're going to register a payment service is what we're going to go through and do. We're going to create a role with a tag. The tag is going to have that it is a payment service. We're going to set the lease for the TTL to 1 hour and with a maximum of a week. And so this is how we would do. We would go into Vault. We would write into our guide roles, payments role. We would then, the token name is payments. The mesh is the default mesh. Here is our TTL. And then we have our tags. So we go ahead and do that. Successfully written. Now we have our roles. Just to show you this, you can see here as we've been creating these policies, here are the policies that are associated to these roles, by the way. So you can dig through this, this as well in this demo. All right. So now we need to create a policy that is going to leverage that role. So what we need is create a policy where they can default in the default mesh and get the payment service. So we're going to do that here. We're going to enable this. So we're going to do a vault write. We're going to write to this role. We're going to tell it the TTL, the max TTL, the policies. We're going to give it both the default and the payments policy, and then find the secret ID. And then this is what that policy would need to look like in Vault. This is a Vault policy. It's all path-based. So we're going to give the read capability on the secrets engine, credentials, the payments role. When you call the credentials creds, that's what does the tells the plugin to grab creds. All right, I'm going to copy and paste this one because for some reason it doesn't like the
end of file type of.
Yes, it does not like the end of file work. All right, so we should now have yes, and so now we have that file there with the policy. And now we can register it. So we're going to write payments policy with that specific policy file. All right, so now it's uploaded. Just to show you that, we go back to our policy. We have our payments policy, and then there is our policy right there. All right. Okay. So now we need to generate our app role information. This is basically generating our metadata type stuff. So we're going to go ahead and do that. We're going to write it out to the specific, or no, sorry, I lied. We've pre-generated our app role ID and secret. We're going to log in with our app role and secret. So we're going to do vault write to the auth/app role login. That's the method that you use to log into Vault with app role. So we're going to
right
go ahead
now
and do that.
It's nothing to do with Kuma yet. So we're just trying to
correct.
configure
We're not
new
correct.
policy.
Yes. Yep.
New
That's exactly
policy
right.
For new services
We're just
going to be deployed.
Yep. That's exactly right. And so with that, we log in and we get back a Vault token. And then we also get the policies associated to our token and then the lifetime of this Vault token. So we've done that. Now what we need to do is, rather we can copy and paste that all around, but we can just export that into a command here. So we'll run that. That exports the token. And now we should be able to run this command to read our payments role. And so now we have read our payments role. We can copy and paste this here. And you can see that we have a payments service with in the default mesh, and it's a Kuma IO service patients.
Now this is the token that we can use for payment service to
correct
authenticate with the control plane.
That's exactly right. All right. So now we've done that. Okay. So if you run this again, so now we are logged in with payments. So what I'm going to do is there's an existing role out there, API role for the API when we first started. Here you have this API. What I'm going to show you is what happens if the payment service tries to request a credential for the API role. What happens there? Well, if I do that, then I get a deny. I get an access deny that I do not have a policy associated with making a request to that. And so I instantly get denied on Vault for trying to make that request to a credential that I do not have a policy associated with, because I'm the payments, not the API role. All right. Now, let's put this all together into the Vault agent, because we went through the manual process of what Vault agent is going to kind of do in the background. But so let's actually create a Vault agent that will do this for us inside of payments. So what we're going to do is we're going to copy and paste this template. What this template is the Vault agent template. It's telling us that we're going to auto auth with app role method. You can use this to any type. We can use this, could just have easily been AWS or GCP. There's a config associated to whatever type of method. In this case, we're using app role, so we need to tell it the role ID and the secret ID. And then what is the template? What are you doing with that? Well, what we're going to do is we're going to actually, with our secret, we're going to request the payments role credential. And we're going to grab the data and the token element from that. And then with that, we are going to execute the, we're going to write that to the dataplane token. So that's what we're going to do with this. We're going to take and we're going to write that out to the dataplane token. Now let's go ahead and do that. So we're going to go into Nano. We're going to create a new agent config file. I'm going to paste my template. All right, Control X. Oh no, Control X. Yes. All right, so now we've saved that here. You can see that's the config file. Now what we're going to do is we're going to start the agent with that config file. So now we've started the agent.
Do we need to have agent per config file, or one agent can handle multiple configs and stuff like that?
I believe that you'll want, so one agent can control multiple configs, but it only will leverage a single Vault login. So if that one Vault login has access to multiple things, it can manage with multiple templates in there. Yes. Yep, that is true. Yes. All right. So now we have bootstrapped up our agent. Our agent is running, and it actually was successful and wrote our token out. Now that we've got and we just did that, we catted our token. Now what we're going to do is we're going to start the Kuma control plane with the token that we just ran. So let's go ahead and do that. We are going to join, and we're going to leverage that token to join our control plane. So starting workers looks good. Let's go down here. And now you can see we have an additional service, a standard service, that is the payment service. And that's the one we just joined right now using those credentials.
That's pretty cool. So
right.
For the future services, what kind of stuff needs to be happen? So we need to create a policy in order to the service will be able to use APIs to generate token, right?
Correct.
So for example, we have another service, order service, that we need to have a policy so this service will be able to request or get access to generation of these tokens, right? Second thing, that we will have an agent that will be listening this policy and will be, generating tokens based on requests from this particular service, right?
Correct. And then I think we have 10 more minutes left if we wanted to do questions. But the last piece of this was just talking about expiry. The tokens expire. And so what we added into this plugin was a little bit extra, which is that right now Kuma handles token expiration you can revoke access by posting to the JTI to a secret. And so in the global secrets, there's a user token revocation, and there's a service token revocations. And then the service token revocations is under the mesh, so it would be under the default mesh. So when you in order to revoke those tokens, you actually have to just it's basically a comma separated list inside of that secret of all the JTIs. So once you put the JTI, anytime someone tries to authenticate with that token, they instantly get revoked. There's not a cleanup process right now in Kuma, but we actually added that into the Vault plugin. So what happens is, you have that TTL and max TTL. When the max TTL expires, Vault will actually go read the secrets list and actually pull the JTI out, because now that token has expired and is no longer eligible to be used anyway. So it actually will keeps the revocation list clean by using the Vault plugin. So yeah. And if you want to play around, this specific page in the documentation shows you how to set up a short TTL lifetime. So we set up one with only 1 minute, and it'll show you how it'll automatically revoke your access, and you won't be able to continue through there. So
very nice, very nice. I'm personally very impressed with this tool and how you can generate not only your demos but also interactive documentation. That's pretty cool. That I need to explore myself, and it is pretty nice experience, like developer experience, to provide this type of tool for your demos. Let me quickly check the chat and see if they have any other questions. There's always good praise to get, and some people actually want to return and rewatch this later. That's gonna be good stuff to learn. So with this, I think, Gregory, do you have a preferred way if people want to contact with you and talk to you about? You probably mentioned this, like GitHub would be right place to start talking, right?
Definitely. Yep. So you can go to my GitHub is just github.gregoryhunt.com. The demo is on the demo-kuma-vault. That's what we just went through today. You can literally pull that down, and as long as you install Shipyard, you can literally walk through everything we did today through that exact same interactive documentation and play around with it all you want. And then the actual plugin itself is in my same GitHub under vault-plugin-kuma. We've got some planned enhancements that we're going to be adding to it. One of those is the secrets. So the auto root rotation, which is what will happen is right now when you add that admin token in there, that admin token lives for a certain period of time. What we're going to do is we're going to add, there's another interface inside of the plugin, the Vault plugin, which allows us to actually have the system generate its own new admin token. So what you can do is when you bootstrap Vault to begin with, you use a short-lived token, like 5 minutes. Then you rotate the root secret. It generates its own new secret, which you could have be for a month or a year, and then it'll continue to do that. And no human will ever know that secret anymore. So now with Kuma, as long as you get into the control plane's local host, you can always interact with the API there. So for some that's always your backdoor in Kuma. But you have to be localhost directly on the control plane itself for that.
That's what I usually tell people when they say, "No, that might be kind of like the vulnerability." But once the attacker has access to your local host, you have different problems to tackle. So Kuma will be not the at least of your concern.
Kuma's not your problem if they're on your local host.
Yeah, exactly. So that was pretty nice, and so now you have it, folks. So you now you understand there's some of the deep insights that happening inside the Kuma and how the Kuma integrates with the services. On top of it, obviously you also can put the MTLS and all these kind of things. But in order to
we didn't do MTLS in this demo, but that it's just enabling that that's enabling Kuma's feature set, and the Vault configuration would not change at all by enabling TLS in the control plane.
So on the control plane and data plane, you will enable MTLS, but still you need to have this token in order to join. So only when the service joined a mesh, Kuma also will be able, or control plane of the Kuma, only if you're using regardless if you're using this built-in CA or if you're using the external CA. So there's another demo that very kind of like asking for trouble is to use Vault as a CA for the Kuma.
That's phase 2. Yep, that's going to be the next thing that in fact, I've been talking to the Kuma team about just that. Yeah, definitely.
Yeah. We do have this integration in the Kong mesh with the with Vault as a CA. And as a reminder, so Kuma is CNCF open source project, and at Kong we actually building some of the additional features, maybe like some of the deep cloud integration that we did for I guess for AKS and things like that. We built some automation for Kuma, and this is kind of like a commercial product, but it's available as a the trial. You can always request a license to play around and see if the Kong mesh is something that you're interested in, or Kuma would be solving all your problems. I would like to say thank you, huge thanks, Gregory, for first of all speaking at the Kong Summit. It's a huge time to prepare and develop this plugin, and I see he's wearing his Kong champion t-shirt. It's the recognition. This is what we try to recognize and say thanks to the people who contribute back to our community. It's great to have him on the live stream. Write down in the comments into the streams and recordings. We do have one quick question, so let me see if I will be able to add this to broadcast. So let me try to see if I will be able to make this slightly smaller so it will fits the screen. Okay, that's the beauty of lifetime. So Mert is asking, I'm currently storing them, I believe, tokens in the file. In what scenario should I switch to centralized management system? Or right now I already have a problems with this env file and I'm not aware of it. Is communication between them MTLS and data already? Yeah. So I think we touched on the second questions a little bit. So we're not using MTLS in this case. But what do you think about the env files and locally stored tokens and things like that?
Yeah, and that's one of the things where generally it's not as good practice to keep. If you can keep your tokens out of in files, because in files can easily get committed, right? And that's where we're talking about. So then you commit your tokens, and then you have to completely invalidate those and generate new ones, or someone can get access. So using this more dynamically generated, it's going to be rotating the tokens. And you're going to have, even if they accidentally got committed, hopefully they would be, even you could be able to revoke them, but then also they would expire, right? And so they would no longer be good after a certain period of time anyway. So yeah.
Yeah. And this is our cue. This is our cue that we are done for today. I would like to remind you that all the things that we described here you can find in the description below. Sign up for new episodes of Kong Builders. And with this, my name is Viktor Gamov, and as always, have a nice day. I'll see you in the next one.